So in part C, we have our multi-unit questions. Now, on multi-unit questions, each part of the question, or the first few parts, all can be solved for on their own. They could just be an individual question by asking them on its own. And then what we'll find is that by combining all of these ideas together, we're able to compute or show a larger thing, where this large integral question here, if I just gave it to you, it'd be very hard to solve. Because we broke it down and had you do each of the parts, it becomes a lot easier. So here we want to use quotient rule to show that this is true. Now, quotient rule is how we take the derivative. So what we want to show is we want to show that the derivative with respect to x of sine x over x plus c equals cos of x over x minus sine x over x squared. And to help with this, what I'm going to do is that we're going to note that this equals the derivative with respect to x of sine of x over x plus the derivative with respect to x of c. Now this, because it's a constant, equals 0. So it equals just the derivative of this expression, which we're going to compute using quotient. F G F prime G prime. F is sine x. G is x. F prime is cos x. G prime is 1. So F prime G is x cos x minus FG prime is 1 times sine x all over x squared, which equals, now using distribution, x cos x over x squared minus sine x over x squared, which equals cos of x over x minus sine of x over x squared. So thus, sine x over x is an antiderivative of cos x over x minus sine x over x squared. Thus, the improper integral of cos x over x minus sine x over x squared dx does in fact equal sine x over x plus c. Next, what we're going to do is we're going to show that this limit, this here, equals the limit as b approaches infinity of b sine b over b minus the limit as a approaches 0 from the positive sine x over x. To do this, we note this expression is an improper integral. The integral from 0 to infinity of cos x over x minus sine x over x squared dx does equal the limit as a approaches 0 from the positive of the limit as b approaches infinity of the integral from a to b of cos x over x minus sine x over x squared dx, which equals the limit as a approaches 0 from the positive of the limit as b approaches infinity of sine x over x evaluated x equals a to b, which we just showed in the previous example that that's the indefinite integral. So when doing our definite integration, we take the antiderivative, plug in b minus plug in a. So it equals the limit as a approaches 0 from the positive of the limit as b approaches infinity of sine of b over b minus sine a over a. And now, this limit, because this sine of a over a doesn't have a b term in it, I can distribute to get it to be equal to the limit as a approaches 0 from the positive of the limit as b approaches infinity sine b over b minus sine a over a. Now, because this whole term has no a's in it, I can distribute the limit over, and this limit does nothing to the first term. So this equals the limit as b approaches infinity of sine b over b minus the limit as a approaches 0 from the positive of sine a over a, as we would like. In the third question, we want to use squeeze theorem to show that the limit as b approaches infinity of sine x over x equals 0. Now, again, we need a function from the top and a function from the bottom. So sine x over x. This is less than or equal to absolute 1 over x sine x, which is less than or equal to absolute 1 over x absolute sine x, this equals, which is less than or equal to absolute 1 over x times 1, which equals absolute 1 over x. Similarly, sine x over x is greater than or equal to absolute 1 over x sine x, which is less than or equal to which is equal to 1 over x. Sorry, this is a minus here. Minus 1 over x absolute sine of x, which is less than or equal to minus absolute 1 over x times 1. And again, the reason to go from here to here and the reason to go from here to here is the same as before. Okay? Which equals minus absolute 1 over x. Okay? We could leave it as absolute 1 over x, or you could say as x is greater than 0, absolute 1 over x equals 1 over x, and minus absolute 1 over x equals minus 1 over x. We're going to go with this second statement, meaning minus 1 over x is less than or equal to sine x over x, which is less than or equal to 1 over x. Now, the limit as x approaches infinity minus 1 over x equals 0, and the limit as x approaches infinity of 1 over x equals 0. As 1 over x is less than or equal to sine x over x, minus 1 over x, less than or equal to sine x over x, which is less than or equal to 1 over x for all as x approaches infinity, and the limit as x approaches infinity minus 1 over x equals the limit as x approaches infinity of 1 over x, which equals 0. Then by squeeze theorem, the limit as x approaches, or x approaches infinity of sine x over x equals 0. And this here should be x approaches infinity, or we should be doing limit as b approaches infinity of sine b over b. Either works. Combining this, we need to use these three to show our limit equals -1. So the integral from 0 to infinity of cos x over x minus sine x over x squared dx equals the limit as b approaches infinity of sine b over b minus the limit as x approaches 0 from the positive, or a approaches 0 from the positive of sine a over a, which equals 0 minus 1, which equals -1. We have our solution. Note that each of these pieces on their own can be solved as if they were their own part B question. But they come together to solve this bigger problem. We break it down into pieces, which you can do each piece on your own. Then we can combine it together in the end to solve this single challenging problem. These are the type of multi-questions that you might be asked.